welcome back to Project Anonymous, and in today's video,
we're going to unbox, set up, and test out a new AtomStack laser engraver.
Let's get to it. So a huge thank you to AtomStack for sending us this brand new laser engraver.
Yeah, so specifically they sent us the A10 Pro V2 12-watt laser engraver, and we're going to go ahead and do some tests with it, set it up, and kind of show you the ins and outs of it as we go through the system.
And this is a diode and open gantry laser.
Yeah, specifically this is a very budget-friendly and capable laser engraver that is actually capable of doing some cutting as well. So we're very interested to see what kind of features this has. I know that it does have somewhat of Wi-Fi capability to integrate with an app, and it does have limit switches, all the bells and whistles there. We're very interested to kind of see what this is about.
And we're probably going to be setting this laser up for LightBurn, because that's kind of the program we usually use.
Yeah, absolutely. So AtomStack sent us their new line of laser, the Ace Pro V2. So the Ace Pro V2 comes in two lines of models, and that kind of corresponds to the laser power that goes along with it. So this is the A10 version, which is a 12-watt laser. There's an A20 version that's 24-watt. Now AtomStack tells us this machine, the A10 version, is capable of cutting 6mm wood in a single pass and 5mm black acrylic in a single pass. Now what AtomStack is boasting about this machine is its speed, and this machine is capable of cutting and moving the laser head around at 24,000 millimeters per minute, which is about 400 millimeters per second, which is pretty quick for a diode machine. The engraving area of this machine is 400 millimeters by 400 millimeters. So enough talk, let's get this out of the box and set up. All right, so we have everything unboxed. Obviously we have our frame here. Here's the laser head itself. It has a integrated air assist nozzle. So it kind of comes out the top to keep wires and stuff all kind of nicely together. So that's pretty neat. I like that that's integrated. Really cool. It comes with full-size tools, and what's awesome here is all of the material needed to put this together, all of the screws and stuff, are organized by steps. So there's no guesswork here on separating the different size screws. But this bag doesn't include the M58. Looks like we're going to end up having to pay closer attention to what screws go where now. For step one, we're going to use everything in this bag. For step two, everything in this bag, and so on and so forth. That's really cool. I like the way that's organized. Obviously, we got some safety glasses. We'll add that to the collection. And we have a connecting rod here because there's a single stepper motor for the Y-axis. So this rod here connects both sides of the Y-axis machines. And then this is a belt drive system using an eccentric nut here to control the tension on the machine. And it looks like it's already set up pretty good, but we'll check that later when we get this machine together. Here's a control unit itself, and what's really awesome here is the integration of some future stuff that AtomStack is going to be putting out, as well as some accessories that you can obviously integrate as you need. So we have an HDMI port here for a screen that you can actually purchase from AtomStack that can control the machine functions with a little touch screen. That's pretty neat. Our USB drive. And then again, a future accessory to this machine is a auto bed Z-axis. So this button here, I am going to assume would automatically raise or lower that bed when you integrate that into this machine. It does have Wi-Fi capability here, and the reason you would use this is with the app. So AtomStack has an app that they've developed to be able to control this machine using your smartphone, which, I mean, that's pretty cool. I'd like to try that out. And of course, this machine is compatible with LightBurn as well as many other laser drivers software. That's a USB drive. We'll check that out later. And a little cleaning rag for our laser head. It comes with a little aluminum pad here you can use for focus length if you're cutting or engraving. It comes with a 5 amp power brick and power cable and some connecting cables. So this screw is not going in all the way because it's hitting the other screw that we tightened here. And if you look at the instructions, they do account for this. So step 2, we're supposed to be using an M5 only 8mm, and these screws are the 14mm screws. But this bag doesn't include the M5 8. That is in step 3's bag where there's M5 by 8 screws. So just make sure when you're tightening this connector here, you're using the M5 8. They probably could have just updated the bag and, you know, put multiple screws in there, but anyway, looks like we're going to end up having to pay closer attention to what screws go where now. That's better. Now we're using the last screw from step 3 over in this corner and one of 2 screws left over from step 2. Okay, so now we're here in step 5, and there's no step 5 bag, but you can see clearly what we're going to be using is the leftovers from step 2 and step 4. Again, I don't know why they would label the bags by steps rather than just what type of screw it is if they're not organized by step. At least all the screws are here, so let's get this last piece on top. This is the M514 screw. I'm just going to slightly secure it here and use our other M514 screw to hold the other end. Now you can tell if we use just this screw, this gantry would just tip over because the heavy side would go towards the bottom. But that's why at the top here, there's 2 drilled holes here for the leftover M36 bolts to kind of screw in on the top to keep this oriented right. Step 6 is connecting the rod from this side here. And then there's a little grub screw there that we tighten on it. So what I'm doing now is I'm going to tighten this grub screw here. So what this is this is a method of connecting both sides of the y-axis together so that the drive motor is here, but it will transfer power not only to this belt, but it will also transfer over to this belt here so that this machine goes parallel at the same time versus one side kind of pushing up while the other one's just kind of being pulled along. Another method that other machines use is they'll put a second drive motor on this side that will be synced up in the board so that both motors move the same amount. This is another, again, just different method of doing it. So we're going to go ahead and tighten this grub screw here, and then we're going to make sure that this bar is parallel to this bar, and then we'll tighten this grub screw here. I'm going to make sure that it's nice and tight so it doesn't spin. Okay, so what I'm doing to make sure that this bar is parallel to this bar is, well, I'm going to bring this all the way down to the lock, and I'm going to line this bar up with our little gridded mat here, and then I'm going to make sure that as I look up at this bar that it is also lined up perfectly with the mat and the grid lines. Okay, so now that it's lined up, to make sure that you have both grub screws tight enough, you should be able to roll this bar and it should drive the belt on both sides. And it looks like it is doing that, so good. And then just to note, there are 2 grub screws on this side. So we'll make sure we tighten both of them. There's one there and one here. All right, so now we'll do some fine adjustments on our eccentric nut here and make sure that this is tight enough. So what we're looking for is that when we lift up a side, this doesn't just come crashing down to the other side. That would mean it's too loose. If it doesn't move at all, it means it's too tight. So that's pretty good. That's actually perfect. Okay, so it came adjusted perfectly from the factory, so that's really nice. It sits nice and flat on the table. Now we will move on to getting the laser head on. So the screws that we need are in the spare bag, but these thumb screws are what hold the laser head on. You just put them right here on the bracket. Perfect. Now it's just cables. Okay, so time to do some connections. Over here on the side, we have a input for our power, but there's also a DC output, I assume for an accessory that you could add to this. And then our computer port is actually USB-C. This USB drive on top, I assume, is for an accessory such as a rotary that you could plug in directly to this USB drive to run a rotary or some other accessory. But what I really like is the cable itself is USB-C, so we can plug straight into our Mac with no adapter. Now it does have provisions for a USB-A type if you want. Now we're going to connect the LightBurn. So our work area is 400 by 400 millimeters, and it looks like I have to convert that into inches here because of how my settings are in LightBurn. So I'll do that real quick. Hey Siri. I think we're set up. Let's see if we can move it. Never mind. There we go. Now we're connected. Let's see if we can move it now. There we go. Same thing happened when we connected other lasers to LightBurn, where initially it was hesitant to connect, but just reselecting the laser here made it so that we had communication with the machine, and we are fully connected now. Let's see if we can get it to go home. All right, so now let's run our test, and we'll cut a 1/2-inch piece of plywood with our concentric circle test design and see how many passes it takes to cut through that 1/2-inch ply. If I can get that to frame out so we know where it is. I know there is engraving as part of this process, but we're going to set it to the cutting height. So real quick, I'm going to check this because you can see that the crosshairs are a distance away from where our actual nozzle is, and we need to make sure in our device settings that this is set up appropriately. Let's do our crosshair test first. We'll do it on this side. And to do this, all we're doing is marking in pencil a set of crosshairs that we can line up with the current position of the red laser, and then we're going to engrave a crosshair and make sure it's lined up perfectly on this crosshair. So we'll get that set up. And to do that, I'm just going to create a new layer here and draw some lines. Here is where engraving is, so clearly it is off, but we can adjust that. So let's move the red laser over this way in the software settings. So in my device settings, I'm going to enable the pointer offset, and this is where we're going to do some adjustments here. So it's our x-axis that needs to move over by quite a bit. We're going to use digital calipers for this. Negative 1.15 millimeters. Okay, now let's see what that looks like. Okay. And let's turn up the heat a little bit so we can get darker lines here. Turn it to 35%, and let's start this again. Right, that time it certainly took. We are almost perfect there, but I'm gonna make it darker so that we can actually see it. We are right on the money now. So you can't even distinguish the difference with the pencil mark and the engraving. I'm glad we checked that first. So now let's see what kind of results we can get with cutting. Now I'm going to select all of our layers except for our little crosshair. And as a reminder, everything else I have set to 500 millimeters per minute at 100% power for all of our lines. And then each concentric circle is going to have an extra pass up to 5 passes, and we're going to see how deep that goes. And if that doesn't cut through this, we're just going to slow down the engraving a bit until we can see a different result. So let's try this out. Let's see if we've cut through this piece. Oh, not quite. So it appears like we were almost there. You can see the outer ring here was almost there. I think with 6 passes we would have made it all the way through. Almost there. So this is just 11.35 millimeters or 0.447 inches in thickness. So this is certainly below what its capability is supposed to be. So let's try 7 passes and see if that will do it. All right, so we'll give it a pass with 7 passes, no pun intended. With this material, I would probably run 8 passes to be safe at the speed that we're doing. That's one thing that we didn't talk about, is we left it at 500 millimeters per minute to keep, the laser moving so we don't get a lot of charring here. But obviously we could slow this down and get different results with less passes. But as it sits, I would say 7 passes at 500 millimeters per minute and 100% power does cut through 1/2 inch ply, which is really like 0.44 or something. It does cut. Okay, so I did something wrong when initially assembling this. I didn't see that slot there. That's where the belt is supposed to go through so that you can make adjustments on it if you need it, rather than how we had it, which was just kind of sticking up like that. So we're going to go ahead and feed that in and get that fixed around all sides. So it's pretty detailed and clean engraving. Here's a USB stick that came with the machine. In addition to some files and software that it comes with, it actually goes here in the USB drive area so that when you use the app, it uses this as like a storage. So pretty neat. You can also put files on here that potentially I think you may be able to print via the app. All right, so I'm here in the app for the AtomStack. We've got this set up a little bit. It's really easy to set up. You just kind of connect to the machine's Wi-Fi with a temporary password and all of that. So you got to connect to the Wi-Fi that the laser engraver puts out, and then you can go back into your app. Okay, so we're connected. And you can pull, photos from your photo library. You can hit this creation button to create this folder. I believe this is being pulled from the USB drive that we stuck into the machine. So if you had files that you wanted to save on the USB drive, I believe this is where you can pull those files to engrave them. But we're going to just use this little creation tool here real quick. This creation tool isn't anything really monumental, but you can draw in here and you could technically engrave that out. So if I hit next, you can see I've now created that. I can move it anywhere in the engravable area that I want. You can select a material and get your settings right. So, we can adjust the settings here. So again, I'm just testing this out here real quick. Let's see. All right, so that's good to me. Again, we're just trying to test this app out. If I go to next, hit OK. This is the page that I wish that you could just get from the get-go, because right now I can home the machine by hitting the home button. And I can move it. And I can hit the start button and it should engrave our little design. Let's try it out. I'm gonna go ahead and stop it because there's really no point in engraving this whole thing out. But again, it is really neat that you can control the laser via an app if you have the file that you want to do that. So that's the app.
Once again, a huge thank you to AtomStack for sending us this laser. We do have a few thoughts.
Yeah, so first, one of the pros that we have here is the ease of focusing. So including that little block for engraving and cutting makes it super helpful in getting it exactly to the right depth that you need to get the laser head at. So that is very helpful. The next thing is the ability to kind of tune down the power to get really, really light engravings. And of course, always having the capability to do some major cutting on 1/2-inch plywood. That's always good. So doing a test grid will be able to get your settings just right to see how light you can get your engravings to all the way how dark you can get it as well. So one thing we did notice about the setup was the bag steps weren't quite organized the way that the steps intended them to do in the instruction manual. An improvement that I'd like to see in the future is that those bags are actually organized with the correct bolts that need to go with that particular step. And that would just make setup a whole lot easier. Not that it was complicated or the fact that we couldn't find all the bolts, because everything was there, but it would have been nice if they were in the proper bag. The other thing we noticed is how many passes it really took to cut through that 1/2-inch plywood. Now, I'm going to say right off the bat, we left our speed consistent along the way, and we could have slowed that speed down to get through that 1/2-inch ply a lot faster, or less passes, I should say. But it did take a while, right? 7 passes to get through 1/2-inch ply. That's going to take a lot of time with a big project. Now, results may vary. So all in all, this is a very capable laser at this price point with a lot of integrated features already in the system. So we're super happy with it. So once again, thank you AtomStack for sending us this laser.
Anyways, thanks so much for watching. I hope you enjoyed this video. Please like it if you liked it.
Like it.
Subscribe if you enjoy our content.
Subscribe.
And turn on notifications to get reminded every single time we post a video. Stay crafty.
And be happy.
Bye.